In this tutorial, we're going to review some of the concepts that we had learned in Unit 2. In this first problem, they give you a line with an endpoint and a midpoint. So, remembering from class, when the midpoint is given, we circle it to remind ourselves the procedure is different. We're not just doing the midpoint formula. We need to find the coordinates of the missing endpoint. So we take this midpoint, write it down again over here, and I scratch it out from the problem, because from each number I'm going to extend an equation. These equations will be following the midpoint formula format, taking the x value from the given endpoint and putting it on the x side, and taking the y value of the given coordinate, putting it on the y side. Because we are missing an endpoint, we have to add an x, an unknown x, and an unknown y to each equation. Remembering to solve these equations, when you have a denominator, you multiply both sides of the equation by that denominator. And this 2 cancels out the denominator 2. And you have 2 plus x is equal to negative 12. Then you subtract 2. And x is negative 14. You're going to follow the same procedure for the other equation. Multiplying times that denominator to get rid of it. And you have 8 is equal to 6 plus y. Subtract 6. And 2 is equal to y. So the missing endpoint we know it's the coordinate negative 14, 2. That should be your answer. Now you have the next problem on your worksheet. Same format, different numbers, which is this problem number 2. And I want you to pause the video for a moment now so that you can work it out on your own. And when you've done working on it, resume the video so that you can check your answer. Alright, and this is the answer you should have gotten. If you need to pause the video for a moment so that you can study how this problem was done, you may do that at this time. Your answer should have been the coordinate point 5, negative 5. Moving on to the next type of problem you have in this review. They're asking you to find the midpoint of GH. GH is this line that's given here. Now remember that when the graph is given, it's even easier to find the midpoint. You can just do this triangle shape from one point to the other, and then you count your spaces, 1, 2, 3, 4. 4 spaces down, and 1, 2, 3, 4, 5, 6, 7, 8 spaces to the right. And all you need to do now is go halfway on each one of those lengths. Halfway of the 4 is just 2, and halfway of the 8 is just 4. That should be your midpoint. Now all you have to do is read the coordinates of that midpoint M. Remember that when you're reading coordinates, you always start at the origin of your coordinate grid at the point 0, 0, and you move 2 spaces to the right and then 3 spaces up, so the coordinates of that midpoint are the coordinates 2, 3. That should be your midpoint. I'm going to have you work on a same kind of problem in the next slide, so if you could pause the video for a moment so you can work on it on your own. And when you're done with your answer, you can restart the video again. So please pause now. Okay, and this shows the procedure you should have followed. You should have found the triangle lengths and height of the big length of the segment RS, and then just go halfway each one of those lengths to this midpoint right here, and all you have to do is read those coordinates. From the origin you go nothing sideways, so 0, 2 up. That should be your midpoint. Here they're asking you to find the length of segment GH. So we can still use that triangle shape to help us finding the length. Remember that we can use the Pythagorean Theorem. C squared is equal to A squared plus B squared. So what you need to do is read from your graph how much is A, how much is B. This is 1, 2, 3, 4. And then this length here is 8 units. And the length that I'm trying to find is actually the C. So C squared is equal to 4 squared plus 8 squared. When you square these numbers, you get a 16 and a 64. Add those two numbers together, you get an 80. Now remember, this is not your final answer. You have an exponent of 2 that you need to cancel out. Remember that to do that, you have to do the square root on both sides. So using your calculator, you find that the square root of 80, you can round it to 8.9. And that would be the length of your segment. You're going to try one of these problems on your own, so if you could please pause the video right now as we move on to the next problem. Work it out on your own, and when you're ready with your solution, you can restart the video again. Please pause now. Okay, and here is what your solution should have looked like. You could have used the Pythagorean Theorem, finding the side and bottom length of that triangle, entering it into your Pythagorean Theorem right here. Remember that when you get C squared is equal to your number answer, that's not the final answer. You still need to square root both sides, and you should have gotten C is equal to 10. Moving on to the next type of problem that you have, they're going to give you a figure, and they're asking you to find the midpoint of RB. So the first thing you need to do is find this segment in your figure. You're not going to be using the entire figure, only segment RB. And that is this segment right here, RB. So that's the one that we need to find the midpoint for. Remember, the easiest way to do this is to create that little triangle from one point to the other. Measure those distances, 1, 2, 3, 4. That's 4 units. To the side, that's just 2 units. And then just go halfway each one of those distances. Halfway of 4 is just 2. Halfway of 2 is just 1, and it lands you right there for your midpoint. The only step you need to do now is to go to your origin of your coordinate grid and read the coordinates of M. That would be to the right and 1 up. So the coordinates of M are the coordinates 2, 1. So the midpoint solution here is the point 2, 1. In the next problem, I want you to try it on your own. They're giving you a figure. They're asking you to find the midpoint of segment KZ. So if you could please pause the video now, work the problem on your own. When you are done with your solution, you can restart the video and check your answer. Please pause now. Okay, and here is your solution for this problem. You should have identified this side as the side that they're asking the midpoint for. Then from that side, you just create your little guiding triangle here. Measure those lengths and then just go halfway of each one of those lengths till you find your midpoint, and then read your midpoint from the origin of the coordinate grid. From point 0, 0, you go left 1 and up 3, so the coordinates of negative 1, 3. The next problem, they're asking you to find the length of segment AB. Remember that length is the same as distance. So they're really asking you to follow the distance formula. When you're using the distance formula, remember you are going to subtract the x's and square it. And then you're going to subtract the y's and square it. And all that goes inside the square root symbol. So let's start do our square root symbol, and then you pick the x's that are 2 and a 5 and you subtract them. 2 minus 5 squared plus, then you do the y's. 4 minus 8. 2 minus 5 is a negative 3 squared. 4 minus 8 is a negative 4 squared. Negative 3 squared is just negative 3 times negative 3, so you get a positive 9. Same deal with a negative 4 squared, you get a positive 16. When you add those numbers together, you get a 25. And so the square root of 25 should be your answer. So your distance, or the length of segment AB, should be 5. Following this exact same method, I want you to try problem number 10 here. If you could please pause the video so that you can work on this on your own, and when you find your solution, please restart your video again. So pause now. And here's the solution you should have gotten for this answer. The distance is 4.47, which if you wanted to round to 4.5, that would also be acceptable. Keeping in mind that when you subtract negative 7 minus negative 5, that is going to become negative 7 plus 5. And when you subtract 2 minus a negative 2, that's really going to become a 2 plus 2. So keep in mind those sign changes. In the next problem, they're giving you some information, and part of what you need to do here is kind of sort out what it is they're asking you to do. They're giving the endpoints of a segment AB. So what that means is you have a segment. Actually, let me draw that segment over here. Point A to point B. They're asking you to find the distance. So that's kind of the same of what we just did in the previous two problems. You just use the distance formula. 1 minus 5 squared plus negative 3 minus 2 squared. That's going to be a negative 4 squared plus negative 5 squared. That's 16 plus 25, which is really the square root of 41, and you may use your calculator to find that decimal answer. Should be a 6.4. Now, if the given point B is the midpoint of segment AC, what are the coordinates of the endpoint C? So what they're really saying is, what you had here, segment AB, what you thought was the end of a segment, now they're telling you that's really the midpoint of a longer segment, so you kind of draw a dashed line to represent the other half of the drawing that they didn't talk about before. That would be point C. The point A and B are given. This is 1 comma negative 3. This is 5 comma 2. But point C is not given, so we represent that as x comma y. They're asking you what are the coordinates of the endpoint C. If you think about the first two problems that we did in this tutorial, it's the same idea. The midpoint is given, and they're asking you to find a missing endpoint. So what we do is the same procedure of a missing endpoint. You write the midpoint over here, separate those points, separate those coordinates, because we're going to be writing an equation on each side. It's going to be following the midpoint formula format, where the x of the given coordinate is given. Here's the x, and then the other x is not known, so it's 1 plus x. For the y's, the negative 3 is given, but the other y is not given, so it's negative 3 plus y. And you're going to be solving both of these equations. Remember, when a denominator is in the equation, you just multiply both sides of the equation times that denominator. You use up this top denominator, top 2 to cancel out that bottom 2, so you're just left with 1 plus x is equal to 5 times 2, 10. And then you solve this by subtracting 1 on either side, and you get that x is equal to 9. Following the same procedure on the other side, you have a denominator of 2, so you multiply times 2 both sides. Use up this top 2 to cancel out the bottom 2. And then you have 2 times 2, 4 is equal to negative 3 plus y. You add 3 to both sides. And you end up that 7 is equal to y. 4 plus 3, 7 is your y. So the missing endpoint C, the coordinates should be 9, 7. This should be your answer for part C. I'm sorry, part B. Part C, they're asking you, what are the coordinates of the midpoint of AC? Well, they're really trying to trick you in this question because we just found out from this sketch here that the midpoint of AC is really point B. So you don't have to calculate anything. You just have to read the coordinates of point B that were given. That's 5, 2. That should be the answer of part C of this question. You have a same type of question next. So I want you to pause the video and try working on all 3 components of this question following the same procedures that we did here. And if you need to keep this screen on your view as you pause the video to work on your problem, you may do so. So please pause the video now as you work on problem number 12. And here's the solution you should have gotten for this problem. In part A, just finding the length, you're going to use the distance formula with these given coordinates. And you should have gotten a 5.8 as your answer for the distance. In the next part, if point P was the midpoint, that you needed to stretch out that line so that you'd find the other end of that line that wasn't really given at the beginning. And then with this given midpoint, figure out what the other missing endpoint would be. And the last question, what are the coordinates of the midpoint of RW? Well, we were told that the point P is the midpoint of RW, so just read the coordinates from the given information. That would have been your answer for part C. Moving on to the next kind of problem. They're telling you that a car travels from town D through town G and ends at town F. So the first thing that we do is we kind of draw the path from one point to the other so that we can see what it is they're talking to us about. How many miles did the car travel? Well, we would need to know this length and this length and add them together to find the total distance that the car traveled. Luckily, we have discussed a way of how to do this. You can find the triangle height and width here of your segment. 1, 2, 3, 4, 5, 6. This is 1, 2, 3. And with that information, you can figure out this length C. So let's do that up here. Segment DG, that would be C squared is equal to 6 squared plus 3 squared. And then you just continue expanding. That's a 36 plus a 9. 36 plus 9, 45. Now remember that you are not done yet. You have this exponent of 2 here that needs to be canceled out. And to do that, you have to do the square root on both sides. And your final answer would be a decimal. Let's round it to 6.7. Then you would need to do the same thing for the other segment here. Read the width of that triangle. That's a 3. Read the height. 1, 2, 3, 4, 5. And so for segment GF, you would find that other C. Using the same Pythagorean theorem, C squared is now going to be equal to 3 squared plus 5 squared. C squared is 9 plus 25. You add those numbers together. You're going to get a 34. And remember, again, to get rid of this exponent of 2, you need to do the square root on both sides. In this case, you get a decimal of 5.8. Now remember, they're asking you how many miles did the car travel, so that's the total distance. So what you're going to have to do is take the initial segment and add it to the final segment so that you can have your total. So 6.7 plus 5.8 will give you a total distance of 12.5. Alright, so every time you need to find the total distance or total length of a particular path where the path is made up of different segments, you're going to have to use the Pythagorean Theorem. However many segments they have, that's how many times you're going to have to use the Pythagorean Theorem. With that in mind, I want you to move on to problem number 14. And I want you to pause the video now so that you can try this problem on your own. And when you're done with your solution, you can restart the video again. If you need to refer back to this problem as you work out problem 14, you can pause the video here. Otherwise, you can pause it at 14, and when you're ready with your answer, come back and check the video. Alright, this shows the answer you should have gotten for this problem. I have highlighted in blue the path that the problem is talking about. There's an electric cable that needs to go from the power source around the table and then to the computer. So each piece, each segment of the path needed to have its own Pythagorean theorem calculation, and you would have figured out 2 different lengths of C. Those 2 lengths, you should have added them together to get your total length of 11.4. In the next problem, they're saying the graph below shows an outline of a piece of land Joe wants to buy. Find the distance around the entire lot to the nearest meter. So here they're asking you to round whatever decimal answer you get to the nearest whole number. So that's important to keep in mind. So if they want to find the distance around the entire lot, you need to add the length of all the sides of your triangle. So the first thing to do is to determine the length of the sides that either go straight horizontal or straight vertical, because we can read those from the graph. Now you can go ahead and count the boxes here. 1, 2, 3, 4, 5, 6, 7. But keep in mind that that's not 7 units, because you're going from a measurement of 10 all the way to a measurement of this intermediate step here between 40 and 50. So we need to understand that that is a 45. If you notice your scale, each block is actually 5 units. 5, 10, 15, 20, 25, 30, 35. So if you count that way, this length is not really 7. 7 times 5, so that's 35. Checking your up and down scale, notice that it still goes by 5s. 5, 10, 15, 20, 25, 30, 35, 40. So each one of these blocks is also 5. So 5, 10, 15, 20, 25. That's actually 25. And these are the values that we're going to be using to figure out our length C here. But the procedure is the same. The numbers are bigger. The procedure is exactly the same. Pythagorean Theorem. C squared is equal to 35 squared plus 25 squared. In this case, you're going to get a big number here plus another relatively big number. Add them together. You're going to find out what C squared is. 1850. And remember that the only way to get rid of an exponent of 2 is by square rooting both sides. And you get an answer of C is equal to, you're going to get a 43.01, which we're really going to round to just 43. Now, it's tempting to think that that's our final answer, but they're asking you for the distance around the entire lot. So remember that you need to add all 3 sides together. So you're going to have to add the C, which we found out was a 43, plus the bottom 35, plus the right side 25. And that total should be 103 meters. That should be your final answer here. Now you have a problem. Same procedure as this one. In number 16, what I want you to do is try this problem on your own. Pause the video here. Try the problem. When you are done trying the problem, you can resume the video. If you need to pause the video on problem 15 so that you can use it as reference, you may. Otherwise, stay in 16 and please pause the video now. Alright, here's the solution you should have gotten for this problem. You had to again pay attention to your scale down here and also on your y-axis to notice that each block is not just one number. Each block in this case is actually 5. 5, 10, 15, 20. And counting that way, the bottom of your triangle should have been 15. The left side should have been 50. And those are the numbers that you use here in the Pythagorean Theorem. Once you solve for that, you get that C is 52.2. That's not the end of your problem. You still need to add all sides together to calculate how many feet of brick will be needed to surround the entire area. So you add them together and your final answer should have been 117.2. So when you're working on these problems, always when you solve for C, go back and check your instructions to see if that was the end or if there was something else you needed to do. In this next problem, they're asking you to use this graph to answer these questions. And I'm going to try to make this a little bit bigger so we can all follow along. They're asking you to find the distance between points J and N. Again, just because the line showing the distance between these 2 points is not given doesn't mean that you have to find another way to do this. You can draw that line in. And once you have that line in, it's exactly the same procedure of the Pythagorean Theorem. So you count your squares. Here you have 5. And here you have 3. And so to find the distance C between those 2 points, you use the Pythagorean Theorem. C squared is equal to 5 squared plus 3 squared. We've done that many times here, so I'm going to go straight to, you get a 34 from these two. Then you remember to do square root on both sides. And your distance, C, is going to be 5.8. That should be your final answer here. Now they're saying if the given point n, and let me clear this up here for you. Actually, if the point n, which is given right here, they are telling you that the given point n is the midpoint of segment JD. You might be thinking about, wait a minute, there's no point D here. Well, what you should understand from those instructions is that part of the drawing is missing. If n is the midpoint, it means that this line should keep going and end over here somewhere, and that endpoint is your point D. So you need to find out what that endpoint is. Again, every time they give you a problem and they start talking to you in the instructions about points or lines that are not showing in the drawing, what they're really telling you is that you have to draw those in because they're talking about them even though they don't show. So, quickest and easiest way to find the other half of this, the missing half of this line is, if you had to go 5 to the right and then 3 up to find the midpoint, you follow that same pattern to find the other half extension of this line. You go 5 over again, 1, 2, 3, 4, 5 again, and then up 3. And that should show you how this line extends, and you have found your point D. It's much easier than using all these formulas. All you need to do is find the coordinates of D, and for that, remember you start at the origin at 0, 0, and you count how many blocks you needed to move to the right, and then how many blocks you needed to move up to get to D. And if we do that, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4. The coordinates of D are 6, 4, and that's going to be your answer here. D is the point 6, 4. So every time a midpoint is given, an endpoint and a midpoint, and the graph is given, all you have to do is determine the triangle steps that you went to go from the endpoint to the middle, and then follow that same step to find the other point. When they ask you what are the coordinates of the midpoint of JD, well, you should know that the midpoint is n because that's what they told you in problem part B of this problem. The midpoint of JD is actually point n. So you just need to read the coordinates of n. Starting at the origin, you go 1 to the right and 1 up. So the coordinates are 1, 1. Following the same procedure, I want you to try problem 18 on your own. So if you could please pause the video. If you need to pause it here to have it as reference, you may. Otherwise, please pause the video now, and after you've worked this out, come back and check your answers. This is the answer you should have gotten for this problem. To find the distance between points E and X, all you needed to do is again the Pythagorean Theorem, counting the blocks. So c squared is equal to 2 squared plus 3 squared. Simplify and solve, and what you get is that that distance should have been 3.6. If X is really the midpoint, so the segment needs to extend all the way to Y, even though they're not showing in the drawing, you extend it. What are the coordinates of that endpoint Y? Well, it's kind of easy to follow. If from E to X, which is half of the line, you have to go down 2 and then to the right 3, for the other half of the line, you should follow the exact same steps. 2 down and then right 3, and you'll find your point Y there. To read those coordinates, please start at the origin, and you move 2 to the right and then 2 down. So those 2 down should be negative, which is why your coordinates is 2, -2. Correct coordinates of point Y. What are the coordinates of the midpoint of EY? Well, they're trying to trick you with information that they gave you at the beginning. The midpoint is point X, so you read the coordinates of point X. That is -1 and then 0 because you don't go up or down. So your coordinates of point X is -1, 0. In this next problem, they're asking you to use the graph here to answer the question. A new line a new line GH, I guess this word is not necessary, a new line GH will extend from point G to the midpoint of AF. So there's going to be a line going from G somewhere in the midpoint of line AF. What is the length of that line? Well, I suppose the first thing we need to do is find the midpoint of AF. You can count 1, 2, 3, 4 spaces down. You count 1, 2, 3, 4, 5, 6, 7, 8 spaces to the right. And just go halfway each one of those distances. Instead of 4 down, you just go 2. Instead of 8 to the right, you just go 4. And that would be the coordinates of your midpoint. Now they're telling me that that midpoint is the point H. And they're asking me to find that length from G to H. Now you could either use the Pythagorean Theorem here and do this triangle and figure out that length, or you can read the coordinates. I prefer using the Pythagorean Theorem. So here's what I'm going to do. I'm going to measure how high that triangle part side is and how long this triangle base is, keeping in mind that my scale does not go straight forward saying each block is 1. Rather, what it shows is that each block is 5, because every 2 blocks I've hit 10 units. So this should be 5, then 10, then 15, then 20. So this length from 10 to 30 is actually 20 units long. And this height here goes from 5 to 15. So it's actually 10 units high. So using the Pythagorean theorem to find the length of GH, I'm going to call this C. C squared is equal to 20 squared plus 10 squared. And we keep on doing this problem the exact same way we've been doing all these other ones. So we now get, there's a 500, and keep in mind that to get rid of an exponent of 2, we need to do the square root on both sides. So we get that the length of that segment, that side C, is the square root of 500, which is 22.36, which we can round to a 22.4. So the length of GH is 22.4. So there's another problem that follows exactly this same format that I want you to try on your own. That's problem number 20. So I want you to pause the video now and try this problem. And after you have found your solution, then you can restart the video. So please pause now. Alright, let's review the solution for this problem. Line BW extends from point B that's given to the midpoint of AC. So the first thing we needed to do is find the midpoint of AC. The way to do that is I counted the squares from A to B, which are 10, and I counted the squares from B to C, which are 6. And then I just moved halfway from B, I moved halfway of 10, which is 5. And then I moved down halfway of 6, which is 3, and I found my midpoint W. Once I found that midpoint W, I traced the line that they're talking to me about, line BW. I traced that line, which was not showing, so that I could see the line that I'm supposed to be trying to find the length for. Once you have the line there, you just then create your Pythagorean Theorem triangle. And using the correct distances from the scales that are given, you determine the bottom base and the height of that triangle, which should be a 25 and a 15. Those are the numbers that you then use in your Pythagorean theorem to figure out the length C. Using that information, you get C is 29.15, which we rounded to a 29.2. Alright, and the last problem that we're going to be seeing here is a matching of your constructions. They're giving you a word bank, a name bank of all the constructions that we learned in class. And we need to be able to identify them. So before I give you the answers here, I would like you to pause the video to see how many of these you can identify. You can refer back to your notes. You can even go to YouTube and find there's plenty of construction videos. Just go to YouTube and search construction of a parallel line, construction of a segment. All these constructions, you can find information there. Once you have your solutions, you can come back and check the video. So please pause the video now while you're trying to match as many of these as you can. Alright, so let's see which ones you were able to identify. This first one here, they are giving you two segments. So that makes you think that the word that you're going to be looking for here should not be angle, it should include a segment. And what they're really doing here is that they gave you a segment here, which they copied the length from here and pasted it in the other line. So that should be construct a congruent segment, which we find here, put it here. In the next one, in class, we had done these many times, but many of you had done the full arc. Maybe it's easy to recognize when you draw in the full arcs, like this, bisecting a segment, but you also need to identify this construction if all they did was part of the arcs on the top and on the bottom. So that should be bisecting a segment. Here, they give you a given angle in solid black line, and then they show you how they placed a third ray in the middle of the angle. And because it's in the middle of the angle, you should be thinking about the word bisecting an angle. So here we have an example of bisecting an angle. Here, these little marks here, curved X's on the top and bottom, should remind you of the ones that we saw up here, bisecting a segment. If you need to visualize it better by drawing in the full half circles, you could do that too to help you understand what we're doing. But notice that in this drawing, they're giving you a point that's not on the line. So that should help you identify that you're finding a perpendicular line from a point not on the line. And that should be this one. Here again, you're doing that perpendicular line, which is the same line that we used to bisect. It's perpendicular, but now they're showing you a point that's on the line. So that should give you a hint that that's a construction for a perpendicular line from a point on the line. Here they're showing you two angles, and they're marking the opening of the angles. Because the openings match, it is constructing a congruent angle. In other words, you're copying this angle over here. So you're constructing a congruent angle. In the next one, it's pretty much the same idea. You have an angle here where they measure the opening and they copy that opening over here on another line segment to produce the same angle. So they are again constructing a congruent angle. Here, once again, we see those arcs coming from the endpoints of the line. So you should recognize that as one of the first constructions that we did, which was bisecting the line segment. They haven't finished the construction yet. You know that to finish the construction, they need to draw that line through the middle. But even though they haven't finished the construction, you should recognize it as bisecting a segment. So I'm actually going to copy that title and paste it here because it's used again. In this drawing, they still have the arcs that we use when we are bisecting a segment or using that perpendicular line through the segment. But here's the important part to notice. There's a point on the line there that they have not labeled A or B. It's just a point on the line. So that should help me understand that they are doing a perpendicular line from a point on the line, because a point on the line is given. And lastly, here we see we have an angle. And the only two constructions we know about angles are either bisecting it, which if they were bisecting it, we would be seeing a line through the middle. And the other one is copying an angle, in other words, constructing a congruent angle. So that's the one that I'm going to choose for this one. And that should be your review to redo this, this unit in a much better way.